In this video, we're going to look at an overview of making buffers. So in a practical, it's fundamental for any lab work that the quality of the reagents you use is considered, that you're aware of the importance of that. And in certain cases, we're able to purchase reagents. They can be of a specific grade of purity or sterile for particular use. So, for example, we always get in our pH buffers ready-made, and you'll use these when you're calibrating a buffer. We can buy in other reagents which are ready-made. Depending on what you're doing, depending on the budgets available, depending on where you're working, you'll have different situations. However, a lot of the time, you'll actually be making up your own buffers on the bench. So I'd like you just to kind of press pause in a moment on this slide. These are two equations in red that we've gone through and I've asked you to remember, and I have two buffers on each side of the slide and follow these equations down to make them. So we've covered this already, but I would urge you to press pause and work down through these, and if you have questions, bring them forward into the practical session. When you're making a buffer though, it's the process that's very important. I want you to be aware about reviewing the concentrations, like in the calculations you just did, performing them, then using a weighing boat, which has been a weighing scale, with a weighing boat that's tiered and zeroed, and then weighing out the salts before transferring them to a beaker. When you do that, you also have to transfer washings to that beaker, and we add some water to dissolve the salts. We don't make it up to the full volume that's requested at this stage. We add a stir bar, a magnetic stir bar, and maybe some gentle heat to facilitate dissolving the salts. If there's pH involved, we have to calibrate a pH meter and test the pH of the solution. Adjust it where necessary. We might lower it with HCl or increase it with NaOH before transferring everything to a volumetric flask with washings before we can add water so that the bottom of the meniscus sits on the line. At that stage then you can cap, invert gently, and have your solution mixed before transferring to a storage bottle for long-term storage, which is labeled with your name, date, contents, and so on. We store this appropriately and then we tidy away, clean our balance and any other equipment. But I would like you to consider with this process the safety considerations involved. So where can you see safety being important? And this little yellow dot at the top, I've thought, well, where can I put this yellow dot to highlight to you where you might put them in? So a lot of people will say your protection equipment like your gloves, your goggles, using your lab coat and so on, but actually you can envisage safety in lots of places. Depending on what you're weighing out, you may need to consider where you're going to do that, how you're going to do it, and again your MSDS sheet should be consulted. Transferring different salts, if you don't want a very fine powder to be in the air, if you're going to heat it, you don't want a vapor in the air that could be dangerous. If you're going to calibrate a pH meter or add acids or bases, you have to consider location, fume hoods, PPE, and so on. Even if you go to cap and invert, you don't want spillages. So we have to be very careful of safety at lots of different aspects, and I hope you see some of those here in this video.